students, welcome to Hari Chemistry. Today we will continue topic limiting reagent. So we will discuss problems based on limiting reagent. So see the problem, A plus B gives rise to A3B4. Initially 6 moles of A and 6 moles of B taken. After the reaction, find out limiting reagent, excess of reagent and number of moles of A3B4. So this is the problem. Okay. So here what is the question? Here we have to find out what is limiting reagent, A or B. We don't know. And which reactant is acts as a excess of reactant or reagent, and find the number of moles of product A3B4. So before solving the problem, first of all we will write the equation what he has mentioned in the problem. So the problem he has mentioned, that is A plus B gives rise to A3B4. So this is not a stoichiometric equation. First of all, here we will write the balanced equation or stoichiometric equation, that is 3A plus 4B gives rise to A3B4. So this is a balanced equation, right? So then write number of moles of A and B given in the question. So that is, he has mentioned 6 moles of A, 6 moles of A and 6 moles of B. 6 moles of, he has not mentioned the number of moles of products. Then write the stoichiometric coefficient. So here the stoichiometric coefficient, so this is 3 moles and this is 4 moles. So means 3 moles of A and 4 moles of B react with each other and forms A3B4. So here the number of moles of product is 1. So you can assume, so this is 1 and this is 2. So take the mole ratio, number of moles of 1 and number of moles of 2. So you will take the ratio, mole ratio of 1 and 2. So that is here 6/3 and this is 6/4. So 3 ones are 3 twos are, and 2 twos are 3 twos are. So here 2 moles of A, 1.5 moles of B. So according to this equation, according to the number of moles, so the B completely consumed in the reaction and forms a product A3B4. So here the less number of moles indicates that is a limiting reagent. So therefore here B is a limiting reagent. And here you can see 0.5 moles is extra than the B. So that's why here 2 moles means here it is more than the B reagent. So that's why A is a excess reagent. So here A is a excess reagent or reactant, and B is a limiting reagent. So here in our problem, B is the limiting reagent and A is the excess reagent. Okay, so then we will do what is the number of moles of A3B4. We will find out number of moles of A3B4. So here you can take number of moles of A by stoichiometric coefficient is 3 is equal to number of moles of B by stoichiometric coefficient is 4, that is equal to number of moles of product Na3B4 by number of moles is equal to 1. So you can take the you consider the relation between a limiting reagent and product. So you will consider only the relation of so B is the limiting reagent, so that's why you will consider the relation of limiting reagent and product. So here the limiting reagent NB by 4, NB by 4, that is equal to number of moles of product by 1. So here we know number of moles of B he has given in the question, that is 6 by 4, that is equal to Na3B4 by 1. So therefore 2 ones are 2 twos are 2 threes are, so that is equal to number of moles of Na3B4 is equal to number of moles of Na3B4 is equal to 1.5 moles. 1.5 moles. So this is our answer. So number of moles of product is 1.5 moles, and B is the limiting reagent and A is the excess reagent. Thank you. Five moles of X reacts with 25 moles of Y. Calculate the number of moles of Z formed in the given equation. So here first of all we will write the equation what he has given. X plus 2y gives rise to Z. So means X plus 2y combines to form Z as a product. Here we will find out what is limiting reagent and what is excess amount of reagent and find the number of moles of Z. First of all we will write number of moles of X and Y given in the question. So first of all we will write the data. Here in the question 5 moles of X and 25 moles of Y reacts with to form product. So we will find out number of moles of Z, that is question mark. Then stoichiometric coefficient, that is 1 mole of X and 2 moles of Y and 1 mole of Z. So you can assume, so this is equation number 1 and this is 2. So take the ratio of 1 and 2, that is ratio of 1 and 2 means that means 1 by 2. So 1 by 2, that is equal to 5 divided by 1 and 25 divided by 2. So is equal to 5 moles of X and 2 ones are 2 12.5. So 12.5 moles of Y. So this is 5 moles of X. So 5 moles of X and 12.5 moles of Y react with each other and form Z as a product. So here based on the number of moles, here X is a limiting reagent. And Y is a excess reactant. Y is a excess reactant. So therefore limiting reagent will decides means here X is the limiting reagent, X limiting reagent will decides formation of product Z will decides the formation of product Z. Formation of product Z. Then we will find out the number of moles of Z formed in the question. Okay. So we will take the mole-mole ratio concept. Mole-mole ratio. We will take mole-mole ratio. Mole-mole ratio. Mole-mole ratio. Mole-mole ratio. So that is equal to number of moles of X divided by, that is equal to 1 is equal to number of moles of Y divided by 2, that is the stoichiometric coefficient, that is equal to number of moles of Z divided by 1. So this is the mole-mole ratio. Here X is our limiting reagent, so that's why it will decide the formation of a product. So therefore we will consider the relation between limiting reagent and product. So therefore here that is equal to number of moles mentioned in the question, that is equal to 5 by 1, that is equal to number of moles of Z by 1. So that is equal to number of moles of Z is equal to 5 moles. So therefore 5 moles of product will form in the given equation. So X is our limiting reagent and Y is our excess reactant. So here we will find. So in this problem, X is our limiting reagent and Y is excess of reagent. So we will calculate the number of moles of X, Y is consumed and how much amount of Y is left over in the reaction. We will see the mole-mole analysis. So here number of moles of X divided by 1 is equal to number of moles of Y divided by 2. So 1 is number of moles of X and Y is stoichiometric ratio of Y is 2. Here already we know very well the number of moles of X. So we will take the relation between these two reactant and X is our limiting reagent. So therefore 5 by 1 is equal to Ny by 2. So that is equal to number of moles of Y is consumed in the reaction is equal to 5 into 2. So that is equal to 10 moles. So 10 moles of Y, 10 moles of Y is consumed in the reaction and we will calculate how much means the number of moles of Y is left over in the reaction. So total number of moles mentioned in the question, that is 25 moles. Number of moles left over in the reaction is, so 20 is equal to 25 moles minus consumed 10 moles. So that is equal to 15 moles. 15 moles of Y is not consumed in the reaction.